Hello, friends. Jim here. Want to discuss with you this article that appeared in the online publication EOS. Deep emission cuts still needed to prevent the worst climate change impacts. A new federal report says the effects of human caused climate change are worsening in every region of the United States, but the technology to address it exists. And this is just published 14 November 2023. I'll talk about this technology angle later on. So here is a photo. Hurricane Umberto, this is Florida, right? Slamming into the southeastern U.S. Right? NOAA photo. So what are they saying here? So scientists released the fifth National Climate Assessment detailing the effects of climate change in the United States. So keep in mind, this report just deals with what's happening in the United States. Now, this is the hyperlink to the report itself. It's up here in this tab, right? Fifth National Climate Assessment. And it's extremely lengthy. And it goes through the climate change risks, opportunities, as well as presenting data of what has been happening, and so on. This is very lengthy. As you can see, the bar is really way up here still. But I will leave the URL link in the comments section for those who are interested in reading through this report. Lots of things: adaptation, mitigation actions, and they break it down by regions. And they tell the climate actions taking place across the regions, etc., etc. And then some carbon dioxide emission pathways. Very high is the most likely one, right? Etc. So as I said, I will leave this, the link to this in the comments section. So what are they saying? They're saying the report stressed that emission slashing efforts are struggling to keep pace with rapidly worsening climate risks. They say there's some good news. The U.S. population has grown in the past two decades, but emissions have fallen from their peak in 2007. But the decrease hasn't been enough to prevent some of the worst impacts of climate change from affecting Americans. Kathy Mills, who's the lead author of the Oceans chapter of this assessment, she's an ecologist at the Gulf of Maine Research Institute, stated, "We're seeing broad-scale impacts of climate change on many different types of ecosystems and many human activities across the board. We have an opportunity still to make choices that will lead to better outcomes." Okay. The fourth National Climate Assessment, which was released in 2018, gave a detailed overview of the economic damage the U.S. faces due to climate change. This year's assessment was originally planned for release in 2022, but was delayed by the Trump administration's efforts to halt work on the report. This year's assessment emphasizes the need for more measures to cut global greenhouse gas emissions or remove greenhouse gases from the atmosphere. The report includes more detail on mitigation efforts already underway and highlights that all emissions and mitigation efforts matter. Each increment of warming that the world avoids through actions that cut emissions or remove CO2 from the atmosphere reduces the risk and harmful impacts of climate change. The new report places greater emphasis on climate justice and environmental justice issues than previous assessments. It's also the first climate assessment to feature collaborations with visual artists with the understanding that together art and science move people to greater understanding and action. There's actually something to be said about combining art and science. It can really help, visualize whatever the concept is for people. A good friend of mine from college, his dad was a medical illustrator. He was an artist, but he also had knowledge of medical terminology, medical processes, and so on. And he did illustrations for textbooks, on whatever. And then later on, he started doing illustrations in museums. So there's something to that. Look at this next chapter here. Earth systems out of sync. That's putting it mildly. It is majorly out of sync. And the reason comes down to is that humans have perturbed the system so greatly that the system, in trying to find this new equilibrium state, is unable to, because the perturbations continue putting things out of whack. And that's why you see, extremes. One day it's 18 degrees and it drops a foot of snow. The next day it's 57 and it all melts. Stuff like that. Or you have a tropical storm that suddenly ramps up to a Cat 5 hurricane in less than 24 hours. The system is out of whack, and that's because humans have drastically perturbed the system. The assessment warns that climate change is impairing many natural processes and damaging ecosystems, increasing volatile weather, especially more extreme precipitation and drought, and the floods that come with the extreme precipitation, is causing challenges for farmers in particular, affecting agricultural production, reducing accessibility and affordability of nutritious food. Right, I've discussed this with you before, that crop yields are decreasing, the nutritional quality content is decreasing. And that was a statement by Carl Bolster, who's the lead author on the report's agricultural chapter. He is also a hydrologist at the U.S. Department of Agriculture Research Service. Just one extreme event can disrupt a farm's entire annual cycle and making recovery difficult. Adaptation and mitigation strategies can help, but the predictability of some of these events will be increasing, causing strain to the entire agricultural sector. That's Michael Koch, an author for the agriculture chapter, also a hydrologist at the same U.S. Department of Agricultural Research Service. When I first saw that name, I thought it meant hyperbolic cosine, force of habit. That's the abbreviation we give for that function. Climate change also heightens the risk that extreme weather and other natural hazards will combine to form compound events. Very true. All right, let's highlight that statement. That statement is very true, and we're seeing that, right? Climate change heightens the risk that extreme weather and other natural hazards will combine to form compound events. And usually compound events tend to be amplifying in practice. In other words, making things worse. When multiple climate hazards occur simultaneously or consecutively in one place. Response to such events can be very difficult for the affected communities. And they cite an example, Hurricane Henri and Hurricane Ida, back-to-back storms that struck the Northeast in 2021, killed 55 people and $21 billion in damages. The compound event was about 30 times more damaging and deadly than, say, Hurricane Henri would have been alone. The things we knew 5 years ago were going to be risked are here. We've seen in all the recent extreme events, wildfires, heat waves, flash floods, precipitation bombs, right? Droughts. Every region of the U.S. is having some version of this. And said Pamela McElwee, who's the lead author of the report's chapter on ecosystem. She's an environmental scientist at Rutgers University. The pace of our attempt to adapt is often not matching the scale of the challenge. Right there. Pace of our attempt to adapt is often not matching the scale of the challenge. Marine and terrestrial ecosystems have felt the effects acutely. I just say all ecosystems. In the oceans, marine heat waves, sea ice loss, ocean acidification, loss of oxygen have all advanced at an unprecedented pace. It's like I've never talked about those things before. You know I have, right? I've been warning about these things here for how long? The oceans, okay, here we go. These changes, Mill said, are a result of the ocean's climate change buffering capacity. The oceans absorbs much of the heat that greenhouse gases have trapped in the atmosphere, like 93% of it. So the other 77% or so is causing all the craziness. Imagine what would happen if just 1/3 or even 1/4 of that heat energy in the ocean diffuses to the atmosphere. What do you think is going to happen? Well, we're seeing signs of that. I mentioned earlier, tropical storms suddenly become Cat 5, Cat 6 hurricanes in less than 24 hours. Atmosphere is warmer. I am recording this video on the 21st of November. This in Fairbanks, Alaska. There is now currently under 6 hours of daylight. And the temperature is in the plus digits. I'm not complaining because it keeps my heating bills down. But at this time of the year, especially Thanksgiving, the joke was, Thanksgiving, it will be 40 below. And right now, I think last I checked my thermometer, it was like 10 degrees above. And why is that? It's starting to freeze over now, but we had the oceans not freezing over. The Arctic Ocean didn't freeze over until late. It's just now starting to freeze in. And you had all that heat diffusing to the atmosphere. But that can't go on forever. As that slows down, we start accumulating more heat in the atmosphere. There'll be dramatic impacts of that as well. As the oceans heat up, they stratify. The ability to sequester the heat to depth diminishes rapidly. And you heat up the oceans, gas solubility decreases. Right? I talked earlier, they mentioned loss of oxygen. Well, you're also going to have CO2 outgassing back to the atmosphere. And we know what that means. Warming oceans have caused marine species to move to deeper waters or cooler latitudes. Where have you heard that before? Changing species distributions and pushing some animals into areas of the ocean where they threaten other species. Many fishing communities, especially indigenous communities, are beginning to suffer because of changes in fisheries. These changes threaten to break vital social, cultural connections by undermining food security and the mental and physical health and well-being of marine resource users. Changes to terrestrial ecosystems have taken many forms. Some have received increased damage from more frequent natural hazards. Others have suffered from more prevalent diseases and invasive species. As the planet warms, the risks are expected to increase. Another thing, and you've heard me talk about this numerous times, as the permafrost thaws, we don't know what pathogens are going to be unleashed. Pathogens that which humans may not have had contact with in over 40,000 years, if any contact prior at all. And then when that starts ripping through the population, all bets are off. So let's see, does that enlarge? It doesn't. Okay, so this little chart here shows U.S. and global changes in average surface temperatures. Okay, this, I have to kind of peer into that. This starts in 1895 and goes up to 2020. And it looks like the black line is the global. These are global average temperatures. Okay, and these are temperature changes in degrees Fahrenheit, notice. Okay, so a degree Fahrenheit increase is less than a degree centigrade increase. Like basically, 1 centigrade is 1.8 degrees Fahrenheit, basically. So if you look at the global, okay, it's approaching 2 here. So that would imply 1C. If you look right here at this black dot. Then there's some other data sources, CONUS in Alaska, showing the U.S. Temperatures. Again, the up and down reflects seasonal variations. But as you can see here, especially starting in about 1970 or so, the trend is definitely increasing. In fact, if you go back to like 1895 or so, overall we see an increasing trend. And we can definitely see an increasing trend in the U.S. Many of the threatened ecosystems protect human communities. Coastal wetlands, for example, shield coastal communities from sea level rise and hurricanes, right? Think of barrier islands, your estuaries, your mangroves, they all absorb the energy. But what's the human mentality? Oh, they're just worthless swamp, bulldoze it over, plop in some, seaside homes, and then when this expensive seaside homes goes floating off into the ocean, how did that happen? Why did it happen? Then people are shocked. Think about all the things that we rely on nature to provide for us. The soil that enables us to grow food, which is being threatened, the water that we drink, right? When you lose the alpine glaciers, you don't have, because the alpine glaciers in past, the snow melts gradually over the summer, providing drinking water, fill up the reservoirs, irrigation, all that kind of stuff. Well, we're losing the alpine glaciers. Well, what are you going to do for drinking and irrigation? And of course, there's the clean air issue. So we're putting at risk the very place we depend on. All of these things I just mentioned are at risk increasing risk because of climate change. The breakdown of such important ecological processes will have consequences for human health and well-being. The report is clear that it's too late for humanity to avoid many of the hazards caused by climate change. But every reduction in greenhouse gas emission reduces climate impact and provides immediate health economic benefits. Now, the U.S. has committed under the Paris Agreement to cut greenhouse gas emissions by 50% by 2030. Well, need to do much, much better than that if, according to the assessment, the goal is to be met. I wouldn't hold my breath. Climate action has increased in every part of the country, with the total number of state-level mitigation activities up 83% since 2018. Okay, so places are taking it seriously. Recent improvements in wind power, solar power, battery storage technologies are promising, said Stephen Davis, lead author of the report's Mitigation chapter, Earth System Scientist at UCal Irvine. Wind and solar energy costs have dropped by 70 and 90% respectively, making the technologies even more feasible for communities to implement. Certainly makes it more competitive and more affordable. Question I have is, why do oil companies still get massive tax subsidies? We actually have more affordable options for cutting emissions than we ever had, Davis said. Last year's Inflation Reduction Act was a huge win to advance mitigation efforts and improve affordability. The assessment authors wrote that many mitigation measures also have secondary benefits for human health, particularly by reducing air pollution. If we're successful in mitigating greenhouse gas emissions, we often will see disproportionate benefits to vulnerable populations, I guess, for example, the elderly. Although improvements are happening, one sector has been stubbornly hard to decarbonize: agriculture. Artificial fertilizers, needed for nearly every industrial crop grown in the U.S., release, wait for it, nitrous oxide. Nitrous oxide is also released from the permafrost as it thaws. Nitrous oxide is a greenhouse gas with 265 times the warming impact of CO2. And livestock also release large amounts of methane, farting away. And of course, we know about methane. To meet international climate goals, mitigation efforts will need to intensify. That could mean a rapid phase out of coal-fired power plants, more investment into CO2 removal, rapid decarbonization of aviation, and long-distance freight transport, according to the report. As adapting equitably, as mitigation efforts improve, communities and governments have also started taking advantage of adaptation strategies. For example, the report notes an increase in nature-based solutions such as coastline restoration, urban tree planting to reduce climate hazards. And then we have investment in infrastructure upgrades, so on. This increase in adaptation, though, is insufficient in comparison to the rate of climate change. I just want that. The report states that adaptation has been incremental, done at small scales. Total of 32 states lack a public adaptation plan, and states with adaptation plans have been slow to implement them. So, the report talks about, a lot of successful adaptation mitigations, etc., but there's a lot to be done. Okay, so what to make of all this? Well, first of all, let's talk about the big elephant in the room. Actually, two of them. One is the ocean heat content. I already touched upon that earlier. You've heard me talk about that numerous times. The report mentions, marine organisms are moving about. There's increased acidification, loss of oxygen, right? Marine heat waves. They didn't talk about the fact that ocean heat content, as the oceans intensify the stratification, will diffuse to the atmosphere. So we can even go to zero, net zero. You keep hearing people talk about that. We can go to net zero like this instant. It won't happen, but let's just say for argument's sake it does. There's still enough thermal inertia, heat content in the ocean that warming will continue. It's locked in. At a minimum, This is being optimistic. At a minimum, we probably have a 5C warming locked in by 2100. That's optimistic. The models I'm seeing, especially the PIK, other researchers, are saying 7 to 11. It's all kind of moot because 4C, humans will kind of be driven to extinction. We just now recently had 2 days in a row crossing 2.0 C. That mean we hit 2 degrees C by the end of this decade? Quite possible. And here's the other big elephant in the room. Overpopulation. The more people that there are, the more demands on dwindling resources there will be. The more energy demands there will be. You cannot keep having exponential population growth on a planet with finite resources. It is not sustainable. And it's not just the energy, but it's also, for example, overfishing the oceans. About 50% of the world's population rely on their protein from the oceans. Overfish the ocean, productivity, primary productivity drops off, the whole system will collapse. And then there'll be nothing to fish out. So, they're trying to say, oh yeah, there's some nice things happening. There's still some things that need to be done. It's a lot more serious, a lot more dire than they're making it out to be, in my view, based on what I'm seeing. So there you have it. A lot that needs to be done. Will it be enough? I'm not optimistic. And even if we did do a lot of mitigation and cutting of greenhouse gas emissions, there's a lot of things already locked in place that are going to keep exacerbating. The positive feedback loops are going to continue. It's going to be a wild century. So there you have it. And as I said, I'll leave the link to this, this report if you want to go through it. They put a lot of work into it in detail. Well, here's that chart. There we go. We can see it a little better now. And then rapid and unprecedented changes. Present-day levels of 800,000 years. Present-day levels of greenhouse gases in the atmosphere are higher than at any time in at least the past 800,000 years. Most of these emissions since 1970. Past 3,000 years, the rate of sea level rise in the 20th century was faster than in any other century in at least the last 3,000 years, 30 centuries. 2,000 years, global temperatures have increased faster in the past 50 years than any other time in the past 2,000 years. 1,200 years, the current drought in the western U.S. is now the most severe drought in at least 1,200 years and has persisted for decades. As you've heard me say before, it's the rate of change that matters. And the rate of change is unlike anything we have data for, ever. Including going all the way back to the KPG event, and including the TM, hothouse Earth times. Even then, the warming was a lot slower than it is today. So this is it. It looks like they're carrying some folks here carrying a solar panel. I got the workbench set up. Cool. So that's it for this video. Thank you for your time.